this skill is evaluate algebraic expressions. The learning goal for this skill is looking at substitution for both number sentences and real-life context questions, and look at expressions in a table of values. The success criteria for the skill is to create algebraic expressions and evaluate them by substituting a given value for each variable. I've taken a few examples from this skill which can be found in the patterns and number topic within number and algebra strand in essential assessment. This first question here, we are going to look at evaluating this expression when a equals 4. Now, evaluate is just a fancy word for solve or to get the answer to, and we know evaluate just has to do with equals, okay? So we want to get a certain expression, get the answer to it when a is equal to 4 and the expression is here. In other words, all this is saying is wherever you see an a within this expression, we're going to replace it with what a is actually equal to. In this case, it's 4. So what we're working out is 17 plus 4. It's that simple. This will give us the answer 21. Again, you'll get an example that looks like this. Evaluate the expression when a is equal to 3. And then we have 6a. Now, people assume that, oh, okay, I'll just replace the a with a 3, and then the answer is 63. This is a very, very common misconception that students have, because in algebra world, if you paid attention in the previous video, 6a actually means 6 times a. Okay, there's an invisible times that's in between, and the reason why we don't write that times is because it can get confused with the letter x. So we'll leave it in this form, but what this actually means is 6 times a. And now that we know that a is equal to 3, what we're working out is 6 times 3, which is 18. So be very, very careful of that whenever you see a number and a letter next to each other, in algebra world, that means that number times that letter. In this case, because a is equal to 3, it is 6 times 3. This example here, it's a bit cropped off, apologies, but it does say evaluate this expression when a is equal to 5. We have the opposite of multiplication, which is division. Now, it does put it in the format of a fraction. If you were to just replace the a with what it's meant to be, 5, you get 60 over 5. All this means is 60 divided by 5. It means the same thing. I can prove this to you with a calculator. If we were to do 60 divided by 5, we get the answer of 12. Then also, if we were to write this as a fraction, 60 over 5, and press execute, we still get the same answer of 12. This is because this is the improper version of that fraction, and in order for us to change it into a mixed numeral, we have to see how many times 5 goes into 60, and then whatever remainder is a fraction. In this case, there are no remainders. It's just 12. So this is why this fraction line is also the same as division, just depending on how we write it. You can use a calculator to help you out in order to get the right answer for this type of question. Hopefully by now you are getting the aspect of how substitution works. We are substituting a certain number, a certain letter rather, with a number that has been provided within the question. In this case here, 3x minus y, we're going to evaluate this if x is to be equal to 4 and y is to be equal to 3. So anywhere we see an x, we're just going to replace it, in this case, with a 4, but remember it is 3 times 4. Okay, so that's the first part. And then we are going to subtract whatever y is equal to, which in this case is 3. So we have 3 times 4 minus 3. Now we have to use our BidMath skills in order to work this out. Multiplication must be done first. So 3 times 4 is 12. And so we have 12 minus that 3, that's a tag along there. And this will be 12 minus 3 is equal to 9. So our final answer is 9, okay? Please make sure you don't do 34 take away 3, okay? Remember, there is that invisible times between the number and the letter. Now we're going to look into questions that have some real life context to it. And this is where we can use algebra and a certain formula to help us out, in this case, a distance traveled, depending on what the speed and what the time is for a certain, in this case, bus. So we're going to look at this. How far will a bus travel if driven at a speed at 65 kilometers per hour for 2 hours? And we're going to use this formula to help this answer. So we want to find the distance. What we do need to put in, so to get the distance, which is d, we need to find the speed, and the speed's been given to us in the question. The speed is 65 kilometers per hour. All right, so we know we're traveling 65 kilometers per hour, and how you read the speed is within 1 hour, if we're going at a constant rate or constant speed, we'll be 65 kilometers away from where we started within the first hour. And all we're doing is just multiplying this by however long we've been doing this for, which in this case is 2. So we're seeing how far we've traveled within 2 hours, and that makes sense. If we traveled 65 kilometers in 1 hour, because that's the rate, to get the next hour, or to get 2 hours, we just double that or multiply it by 2. So 65 times 2 will give us 130. Or in other words, we have traveled, assuming that this has been a consistent speed that the bus has been traveling for 2 hours, we have traveled 130 kilometers. So this answer here. This example here is the same concept, but this time we're just using a different type of formula. Still the same context. What is the average speed of a car if it traveled 360 kilometers in 4 hours? So we have this car that's right here, and it's terrible drawing, and it's traveled for 360 kilometers. And we want to know what its speed is. How fast has this traveled if it's taken this car 4 hours to get there? Well, if it's taken 4 hours to get there, we want to just split this 360 into 4 parts. So that way we can get how much one part or 1 hour will be based on this kilometers that's traveled. And this is where that formula here comes into play. Speed is equal to the distance. So this is RD, distance, divided by the time, or a time frame, which is 4 hours. So all you would do on the calculator is do 360 divided by 4. So the average speed is 90 kilometers per hour. 90 kilometers per hour, because it's 360 divided by 4. The next set of few questions, the 4 of them here, or 3 of them rather, we're looking at number patterns based on a certain expression. Now, it's a bit confusing to read at first, but all this is saying is that we have a set of numbers here. We've got 3, 10, 15, 20, 50. Essentially, you can choose any number that you want. And we'll put this, we'll make all of these letters be T. Okay? So T is equal to 3, T is equal to 10, T is equal to 15. For this given space, okay? So T is the thing that varies, it changes, okay? And then what we want to know is, hey, if we input 3 into this expression here, what will our result be? So in other words, let's say we've got 3 as our first T, and this expression says T plus 15, or in other words, what's 3 plus 15? We know this to be 18. We say, cool, when T is equal to 3, this expression is equal to 18 based on this rule. What happens if T is equal to 10? If we put T equals 10 into this expression, 10 plus 15 is 25. So now we've got a different number based on a varying T. And we just keep doing this for all the different T's that we have. If T was equal to 15, 15 plus 15 is 30. If T was equal to 20, 20 plus 15 is 35. Heck, if T was equal to 50, 50 plus 15 is 65. That's all there is to it, okay? All we're doing is just substituting not one, but multiple values into the expression that's provided here to get an output, all right? So this here is your input, and this here will be the relevant output. If you put in a different input, you'll get a different output, generally speaking, depending on what the expression is. In this case here, for this example, 2x plus 7, 2 times 2. Remember, there's an invisible times. This is 2 times 2, which is 4, and 4 plus 7 gives me 11. Okay, so when x in this case, we change a letter. When x is equal to 2, when we substitute it into here, we get an output of 11. But what happens if x is equal to 5? 2 times 5 gives me 10. 10 plus 7 gives me 17. So our output is going to be 17 in this case. Okay. I'm going to see how you guys go with these three different numbers. I'm not going to fill this in, but I will show you the last example here. And we've got this term that some of you may have not seen, some of you may have. It is x squared. And all x squared just means is x multiplied with itself. Okay, and that 2 that's here just tells me, well, how many times am I multiplying x by? So in other words, if I were to have the expression x to the power of 3, this is just x times x times x. There'll be 3 of them because this power dictates there are going to be 3 of them that are being multiplied by itself. So this is really simple. I'll do the first two. All we're doing is, if x is equal to 4, x squared is just 4 times 4. And we're doing it twice because the power is 2 there. 4 times 4 is 16. So our first output, when the input is 4, will be 16. And the second output, if the input is 5, is just 5 times 5. And that will give me 25. Okay, what we're doing, squaring the number. And the reason why it's called squaring is because whenever you multiply a number by itself, when you are to rule this up into a table, there's our 5 by 5, which gives us the 25 squares, but every single time you square a number, you always make the shape of a square. Obviously 5 times 4 is not a square, that will make a rectangle, and 2 times 1 will also make a rectangle. In fact, any number times another number will be a rectangle unless the numbers are the same. And this is why we call squaring the number. Okay, so go ahead and try these 3 answers well and the rest of this skill. And I'll see you guys in the next video. Take care and bye-bye.